Hey there, my name is Zaid Lobo, and I am a part of the Virtual Reality Club at the University of Illinois. And this is the first in a series of video tutorials on creating virtual reality applications through Unreal Engine 4, or as we call the course here, VR Drift. So this is going to be a quick refresher for some people who've done computer science before, or a new concept for those who haven't, on objects and scope. And we are calling this section just for reference. Cool. And that's a little bit of a joke towards object references, but we'll get to that soon. And for those of you who have done this before, I'd say definitely stick around. There's a nuance to objects that we'll talk about that is specific to game development, and it's definitely something that you should stick around for, listen for. It might help you in the future. Awesome. So let's get right into it. Let's talk about what an object is and why it's so important. So, on an object, sorry, I'm just looking at my desk. It's really messy, but there's a lot of things on here. Let's see, I have an eraser for my writing. I have actually a $2 bill I got for Christmas. It's pretty neat. And I also see some batteries that I use for my VR controllers. And what is common about all these objects? What can these objects do, and why are we using this sort of paradigm in programming? So the neat part is that all these objects themselves are self-contained. So self-contained. So that means that all of these together are their own objects. So an eraser is itself. It cannot. It's weird that I'm saying this, but an eraser has its own properties. For example, I can name my eraser. I know it's weird, but let's say I have an eraser that looks like a little pig. It's a pink one. I can name my eraser Sparky, and I can erase with it. I can throw it at the wall. There's certain things I can do with that eraser that I can define it to do. So its most common things that I can do with it is pretty much erase. I can name the eraser and then I can erase with it. So it's self-contained. It has its own properties. It has its own values. The second thing I wanted to talk about is that all of these objects are modifiable. So I can take all these objects and change it. So for example, I take that $2 bill and I can fold it into an origami crane. So it can modify, I can ask the object to modify itself, or I can take it and do something to it to modify it. Yeah, that's the second point. The third point here is that these objects are influential. So I can use these objects with each other and modify the state of it. So for example, I can take my eraser and I can rub it against my $2 bill, and the eraser will get smaller. It will get lighter. So that $2 bill just caused that eraser to become lighter, to become smaller. Whatever you have, it can modify other objects, and that's why they're influential. The fourth thing here is that these objects are all replicative. Replicative? I cannot talk. Replicative. Don't know how it's pronounced. I don't even know if it's a word. Let's just say it is. All these objects are not the only one of its kind. So I can buy more erasers. I actually have 4 different batteries on my desk that I'm charging. There's definitely more than one $2 bill in the world. They all can be replicated, but they don't work together. So if I fold one $2 bill into an origami crane, that does not mean that every other $2 bill gets folded suddenly into an origami crane. They're all their own different objects, but they have the same attributes to them. So let's see how that can work in programming. So let's start with a quick example Let's see if I can make a really quick example. Let's say, oh, whoops. Give me brown. There we go. So let's erase that. So let's make an example. Let's say I'm trying to make a game of chess. And this isn't going to be a very complicated example. I just have a chessboard of some kind. Let's say that's part of a chessboard. And I have a piece like a pawn here. Actually, the pawn should be up further, but for the sake of example, let's put some pawns here. And let's say we have a piece up here. I do not know how to play chess, so excuse my drawings. There's a horse piece, isn't there? There we go. God, I'm gonna get so much hate for this. All right, so let's say there's pieces over here, and let's say there's this big game of chess going on. I want to be able to call out to a specific piece and tell it to move in a certain direction. And what makes this so nice is that I can ask the board to find a specific piece. So let's say I click on this pawn right here, and I ask the pawn to move forward some number of spaces. So that pawn I have to, first of all, reference. So I have to call out to that pawn and tell it, hey, move forward. Or I can tell the board, hey, board, find the pawn at this specific location and move it forward. So there needs to be some sort of way I can communicate with the board very easily. And when you set up the program as an object-oriented program, where I have different pieces that are constrained as different objects, it makes it so much easier. Now, that sounds very, very confusing, but let's keep going. I just need to explain a couple more things about objects. So let's talk about what objects have. So object specifics. So what do objects have? Objects will have a name of some type. And this isn't necessarily what you need to name the object, it's just what it's referred to as in code. So I can name my chess piece a pawn 1. And that will be the name that's referred to as in code. A object will also have attributes. For example, I can refer to the pawn as its so location. And for those of you who do know programming, these are called local variables within the scope of the object. So the location is like E4. I don't know how chessboard works. I can say the color of the pawn or the side of the pawn is white. I can tell whether the piece is dead, and this can be true or false. So I'll say false. Actually, yeah, that shouldn't be true. And there's different attributes you can give that specific object that can help you search through a bunch of objects to find a specific pawn that might be at a specific location, or find all the pawns of that color, whatever have you. The third thing is we have functions. And these are object functions. So let's say I want to move, I want the pawn to move forward. I can say move, and with the move function, I can tell it, hey, move forward 2 spaces. Actually, I can do that, move, or I can tell it to die. Let's say that another piece hops over it. It figures out that it was hopped over. I just call the die function, and it will change that dead attribute to true. And there's no such thing as change sides. You can't change sides on the chessboard, so forget that. Awesome. So there's a few things that you can do with object specific attributes, functions, name. So let's talk about how this is useful in programming with another example. So let's do another example. And let's say here we have a bunch of houses. And I just recently became a really big dog person. I really like dogs, so we're going to talk about dogs. Let's say I live in this house, and I have a dog. Cool. And I want to, my entire life goal is to get this dog to roll over. All right. So what are the things we need to do to get that dog to roll over? One is we need to call it. Actually, we should probably do operation get dog to roll over. That's what we're going to call it. All right. All right, so the first thing is we have to call out to the dog. We have to somehow ask that specific dog to roll over. And let's say I gave it a name. Let's say I called, so the first thing we need to know is the name of the dog is, Milo. So I say Milo, and then the dog will look at me. But also, the dog outside the window looks at me. You know why? Because that dog's name is also Milo. That dog's weird. But these dogs are both named Milo. And I know it sounds like a crazy coincidence, but because you may have so many different objects of the same name in programming or of the same type, you need to be able to specify the scope. So because of that, we need to know the scope. And what scope is it defines where you're looking for that dog. So I am looking for Milo in my house, so my specific house. And that is called a local scope. So within the scope of my house, I am looking for a dog named Milo, and I want that Milo to respond to me. And we'll talk about this more once we get to Unreal Engine, but that is how we call out to the dog named Milo. And then we need to tell it we need to give it a command. And that command is rollover. And so we need to somehow teach Milo how to roll over. So when we define Milo as a dog, or when we give Milo Milo's functions, we need to define a function called roll over that will cause Milo to roll over. And that's essentially how we're going to work with object-oriented programming. And I'm just going to make a new page really quickly. And we're going to do one last example before we head out. All right, so the last example here is going to be the Snake game. I don't know if any of you have played Snake, but we are going to make a... oh, whoops, did not change the color of the... All right, so Snake game. We're going to Snake. And the Snake game is played on a grid. You have a snake that might be somewhat dark green. And let's say that snake is turning around real quick. Let's put some eyes on the snake. And the goal of the Snake game, if you haven't played it before, is you have to go around and eat fruit. And so that snake will grow... that snake will grow bigger. And so you're trying to get to the largest size snake you can. And when you use the arrow keys, that snake will start moving in that specific direction that you tell it to. So that snake, and its eyes are in the front, it's moving forward. So let's define some functions for that snake. Let's let's say we're trying to make our own version of the game. We can make we'll start with some attributes. And we'll have some functions as well. So let's start. Where are the attributes we want to give this snake? Let's start with, we can do the current direction. Current direction. And that will tell us every time that we want the snake to move, we just look for what the current direction is and we move the snake in that direction. We want to know how long the snake is. So length, because every time that we eat a fruit, we want that snake to grow longer. So that's another attribute for a snake. Another thing we want to know, and this is a little more complexity to it, and we'll get more into that as we keep going, but we want to know it's going to be some sort of, it's going to be a list of locations. So we want to understand where the snake is, because every time we move forward, we need to go in that direction, and then this needs to eliminate the last element. So we need to move forward every single time. We just add a block to the front in the current direction, and then we can lop off the snake behind itself. So we need to update its location. So we need a list of locations so that we keep track of where that snake is. So every time we ask the computer to display where that snake is, it can just plop in those coordinates and then draw some blocks there so we can get a snake. Functions. Let's go with move. So that function's called on event. So let's say we want the snake to move once every second. So every second we'll call the move function, and the snake will move in that current direction that it's going. The second function that we might need is, eat. So let's say we ate that fruit at the bottom over there. We want that snake to grow in length. So the eat function will just add 1 to the length. It will also change the list of locations a bit because it will add an element to the specific block that it's on. The next function is probably die. This is an interesting one because it will be check death. So, oops, I can't spell. Check for death. So the game seems simple, but the thing is that if the snake touches itself from the head to one of its body parts, you lose the game. So let's say that snake will go this way and then touch itself and form a loop. The snake will die. So that's how you lose the game. So on every single time that you move, you should also be checking for death. Now these can be in the same function if you like. I'm just listing them separately so that I can itemize these in a good order. The last function that I can think of is change direction. And this will be called every single time that a player presses an arrow key on the keyboard so that they can change the direction that the snake is going. And that is pretty much everything for the snake game, and that's how you operate it as an object. While we have the snake here, there's other objects that are in play here. So for example, fruits. There can be multiple fruits too. And we need to have like a spawn function for it. So if you like, take the time to write out the attributes and functions that you think you would need to create fruits, to have them be eaten, and sort of think about how that will go and how that will play out. But that's it for the talk on objects and scope. If you have any questions, feel free to reach out to me, and I'll see you in the next video where I'll be talking about game loops and how those help to progress a game along. Cheers.